Next, we've already heard live from Heidi, who's on fieldwork in Svalbard, but she's recorded a presentation for us on glaciers and snow cover and their impact on water resources. Heidi Sylvester is a glaciologist working on the dynamics of glaciers in the polar regions, and she's currently, as you just heard, on a human-powered, i.e. on skis, expedition in Svalbard. She's an active and prolific science communication consultant in both education and policy-related arenas. And we're going to hear a short recorded talk that she made earlier for us.
So today, I would like to highlight the importance of glaciers for society. Even though glaciers are smaller than our ice sheets, glaciers actually were the largest contributors to sea level rise during the 20th century. If you look at the map on the left, the black patches delineate glaciers all over the world, while blue areas of different sizes show the potential contribution of these glaciers to sea level rise. Today, all over the world, glaciers are melting, and this mass loss is very much accelerating. While the largest glaciers can contribute significantly to sea level rise, the smallest ones, the ones you can barely see on the map, are actually the ones which have the most significant influence on human populations in terms of water supply. So I will now include snow to this presentation, as glaciers and snow often play similar roles for populations and ecosystems. The main service provided by snow and ice is to provide fresh water when they melt, partially or totally. This water can be used for drinking, for sanitation, irrigation, for the production of hydroelectricity. In some regions, like in tropical areas and in the northern Andes, glaciers are the only consistent and reliable water supply for local and indigenous people. In other regions, seasonal snow is among the most important water resources, such as in southwestern US. When glaciers melt and less snow falls every year, it leads to a range of impacts, such as a heightened risk of natural hazards, great difficulties for local economies that are connected to recreational winter activities, the loss of climate archives, and a reduction in human well-being through cultural impacts. So now we're going to review different geographical areas where glaciers are found and investigate projections that have been made for these glaciers up to the year 2300 based on different emission scenarios. And we're going to see how much of these glaciers could be left by 2300, depending on the emission scenario we could decide to follow. So in red are the projections for the highest emission scenarios, in orange the middle of the range scenario, and in blue the low emission scenario. When the curves reach the bottom of each graph and the value 0%, it simply means that there is no ice left. So first, let's take a look at these tropical glaciers. There are still some glaciers left in the northern Andes, in East Africa, in Papua New Guinea. Unfortunately, for most of these glaciers, an increase in temperature of about 1 degree Celsius is already too much. Very few glaciers will survive beyond 1.5 degrees. So now let's move on to mid-latitude glaciers, where ice loss is also accelerating. In those regions, all of the ice will be gone by 2300 if we keep following the high emission scenario. But fortunately, there are other pathways we could decide to follow instead. And if global temperatures remain at or below 1.5 degrees, glaciers could preserve up to 40 to 45% of their mass by 2300. And in Central Europe, which is the graph in the lower right corner, if you pay attention to the blue curve, which is a 1.5 degree scenario, we could even get some regrowth of the glaciers, but only if we stay at or below 1.5 degrees. Now let's take a look at high altitude and high latitude glaciers. There again, the differences between pathways are large. And of course, by following the low emission scenario in blue, we keep much more ice by 2300 than with the other scenarios. It is worth noting that emission scenarios in red lead to an almost complete loss of ice in the northern and southern parts of Central Asia, where hundreds of millions of people rely on this precious water supply. And finally, let's focus on snow. Our current observations reveal that the presence and persistence of snow is changing all over the world. Snow seasons are getting shorter every year, and snow covers less ground than before. In the UK, economic impacts related to reduction in seasonal snow cover are significant. Less snow affects the quantity and the quality of river flows. Less snow also means less protection for overwintering crops and vegetation from frost. Warmer winters lead to drier soils, making them more vulnerable to wildfires. And finally, less snow impacts winter sports and tourism. So the only way to preserve as much snow and ice as possible and protect our water resources is to urgently reduce our emissions and follow a 1.5-degree trajectory. Thank you for your attention.